All right, our last section in Chapter 4 is talking about application or real-life word problems. And when we talk about word problems, two terms usually come up: angle of elevation and angle of depression. Now, the angle that we use all depends on the wording of the problem. If we're looking up at something, it is an angle of elevation. If we're looking down at something, it's an angle of depression. Now, this picture is very powerful because you'll notice that we have a right triangle here, which means we can use SOHCAHTOA, and the angle of elevation is inside that triangle, but the angle of depression is outside of that triangle. Now, because of the alternate interior angle theorem, those two angles are actually congruent to each other. However, a lot of students will make the mistake and think that this angle right here is the angle of depression. So this is not the angle of depression. So the angle of depression is outside the triangle, the angle of elevation is inside the triangle, and they're going to be equal to each other. So let's look at these problems down here. Example 1, an engineer erects a 75-foot vertical cell phone tower. Find the angle of elevation to the top of the tower from a point on level ground 95 feet from its base. So we always want to draw a picture. So we have a 75-foot tower. Okay, this is 75 feet, and we know that this point is 95 feet away, and we are trying to figure out this angle right here. So we always, the way I always like to do these problems is write out SOHCAHTOA and label my sides. So here's our angle. This is the opposite side. There's the 90-degree angle, that's the hypotenuse, and this is the adjacent. And I like to underline what I'm given. I'm given the O's, I'm given the opposite side, and I'm given the adjacent side, so I underline the A's, and whichever one has 2 underlined next to it is the trig function I use. So then the tangent of theta is equal to the opposite over adjacent, so 75 over 95. So then to calculate the angle, we're going to use the inverse tangent of 75 over 95, and that's going to give us the angle measure. Now, in word problems, we always use degrees, so we want to make sure that our calculator is set to degrees. So mode degrees. So then the inverse tangent of 75 over 95, and we get 38.29 degrees. So you've solved problems like this in geometry and in algebra too. So this shouldn't look too unfamiliar. Now, example 2 is a little bit more difficult. It says a passenger on an airplane flying at an altitude of 10 kilometers sees 2 towns due east of the plane. The angle of depression to the towns are 28 degrees and 55 degrees. How far apart are the towns? So the plane's up here, 10 kilometers above the ground, and we have 2 towns, town 1 and town 2. And if we're looking at, this is the angle of depression, the 2 towns are 28 degrees and 55 degrees. And remember, the angle of depression is really this line here, this angle here, which is 28 degrees. But we said earlier that this is also 28 degrees. You're going to be saying, well, how do I know 28 goes here and 28 doesn't go there? By the looks of our picture, this angle here is bigger than this angle there, but in all honesty, it doesn't matter. Because when you subtract them, it's going to be the positive distance. You do the bigger number minus the smaller number. So we'll do 28 degrees there. And then this angle will be 55 degrees. So we're trying to find the two distances. Well, we got, and I'm going to draw these two triangles separately so you can kind of see what's going on. We got one triangle. This is 55 degrees, and this is 10. And, that's what we're trying to figure out. And then we have another triangle. This is 28 degrees, that's 10. And this is what we're trying to figure out. So we're trying to figure out the adjacent side in both triangles, and we're given the opposite side. So like here, we're going to use tangent. So for the first distance, we get the tangent of 55 degrees equals the opposite over adjacent. So then we multiply both sides by x. So we get x times the tangent of 55 degrees equals 10. Divide both sides by the tangent of 55. So 10 divided by tangent of 55. We get 7.002. So x equals 7. Just 7. We wouldn't round that up. And then over here, we would have the tangent of 28 degrees equals 10 over y. And you can see it's going to be the exact same steps. We're going to multiply both sides by y and then divide both sides by tangent of 28. So y is going to equal 10 divided by the tangent of 28 degrees. So we can just go up here and change this 55 to 28. And we get 18.801. Not 18.81. And then our distance between the two towns is going to be 18.81 minus 7. So 18.81 minus 7, that's going to be 11.81 kilometers. All right. So these word problems, again, drawing a picture makes them a lot more manageable. So now on the next page, we're going to talk about what's called bearings. And bearings are used when we're doing surveying or navigating, and it's always in terms of our fixed north and south line. And we measure the acute angle. So here you see the angle from our south line is 35 degrees. So we would say that it is south 35 degrees east. So from the south line, we're going 35 degrees towards the east direction. Here, north 80 degrees west is that from the north line going up, we're going 80 degrees to the west. That would be our bearing. And then this one says north 45 degrees east. So from the north line, we're going 45 degrees towards the east. That's where our navigation is going to take us. So this does make it a little bit more confusing in word problems because we really again have to read and figure out what the problem is actually asking us. So it says a ship is 40 miles east and 20 miles south of port. If a captain wants to sail directly to port, what bearing should be taken? So if here's our port, to get to our ship, it says a ship is 40 miles east of the port. Sorry, the ship is 40 miles east of the port, so that would be 40, and 20 miles south. So here is our ship. And it's saying what bearing, to go directly to port, what bearing does the ship have to take? Well, going from the ship to the port, I'm not going to go 20 miles south and 40 miles east. I have to go 20 miles north and 40 miles to the west. Because remember, here's your north, east, south, west. So even though the problem kind of gave it to us in reverse, because I'm asking you if the ship is sailing to the port. So from the ship, this is north, this is east, south, west. So the ship is going to be sailing at some degrees north, west. So we are trying to figure out this angle right here. So again, SOHCAHTOA, this is a right angle, so we know the opposite side of the angle, and we know the adjacent side, so it's going to be the tangent. So the tangent of theta is equal to 40 over 20. So to calculate the angle, we do the inverse tangent of 40 over 20. And it's not complete enough just to say, oh, the answer is going to be 63.43 degrees. So you need to give it in the format of bearing. So we're going north 63.43 degrees west. All right, so the last problem here says an airplane is flying 600 miles per hour, has a bearing of north 52 degrees east. After flying 1.5 hours, how far north and how far east has the plane traveled from its point of departure? So first, let's draw a picture. Here's our plane, and what I'm going to do is I'm going to draw the compass, east, north, west, south, and we are flying at a bearing of north 52 degrees east, so we're going to go north, east. So this is the path of the plane. Now it's traveling at 600 miles per hour for 1.5 hours. That's 900 miles. So that means the hypotenuse is 900 because we're flying at that angle for 1.5 hours. Now we need to figure out how far we traveled north and how far we traveled east. Our angle right here is 52 degrees. So here's our east and north value. So to get the east value, that's going to be the opposite over hypotenuse. So it's going to be the sine of 52 degrees equals east over 900. Multiply both sides by 900. So 900 times sine of 52, and we get 709.21. miles east. And then for the north, it's going to be the cosine of 52 degrees equals the north over 900. Multiply again both sides by 900. So 900 times the cosine of 52. And we get 554.095. That would round up to 1. So 554.10 miles north. So again, you've solved problems like this before, but now we're adding some new terminology to it. So once you're doing your assignment, these things will look familiar. And then just when you use that terminology, I think that will then help you through that. So thanks for watching. Make sure to like and subscribe.